So in this video begins our introduction into graphing polynomial functions, and the first part of graphing polynomial functions is going to be all about discussing the end behavior of a polynomial function. So end behavior is talking about two areas, the left end, okay, and the right end. The left end behavior is going to be discussing what is your output doing as x is going more and more negative. That would be as x is going towards negative infinity. What is your output doing? That's the left end of your graph. The right end, okay, is saying as x gets more and more positive, so as x goes to positive infinity, what is your output doing? So you're describing what's happening to the outputs as your inputs would go to positive infinity and negative infinity. Now before you continue this video, please make sure you have answered these 4 questions. So if you have not, pause the video, answer the questions, okay, and then we'll get back. So number 1, okay, what was the leading coefficient? The leading coefficient of f of x was 5, and the degree is 1. Now, it says, would this be circle? Is this an even degree or an odd degree? Okay, so remember, degree is the largest exponent on x, and now, when I say, is it an even degree or is it an odd degree? Well, look at the degree. The degree is 1. Is that an odd number or an even number? It's an odd number. So f of x would be considered an odd degree. Okay? In number 2, I just wrote it 1, 2, 3, 4. I know on your sheet it's 1, 2, 3, 4. So here's number 2, g of x. What's the leading coefficient? Okay? Let's look. Well, it's in standard form. Leading coefficient is -4. Okay? What's the degree? Degree is 2. Is 2 an even number or an odd number? It's an even number. So, number 3, m of x. Okay, notice m of x is not in standard form, so we should be putting it in standard form so that we can gather all of our information. And now, if we look at it, the leading coefficient is +1. The degree is 4. Is 4 a positive or a negative? I'm sorry, even or odd? It's an even number. Number 4, p of x. P of x is not in standard form. So that should be the first thing we do. What's the leading coefficient? -3. What's the degree? 3. So is p of x an even degree or an odd degree? Well, is 3 an even number or an odd number? It's an odd number, so p of x is considered an odd degree polynomial. Okay, so we can classify a polynomial as being an odd degree or being an even degree based on is the degree an even number or an odd number. Okay, so what we're going to go through now is state the end behaviors for these 4 functions. So we have their equations and we have their graphs. And so we're going to look at what's happening at the ends and why it's happening. Okay, so here's number 1. 5x minus 6, here's the graph. Okay, I'll write it up here again in case you forgot. This is 5x minus 6. And so when we talk about what's happening at the right end, okay, after all of your curves and changes in direction, your right end is what x is going to as it's going toward, what is y going to as x goes to positive infinity, sorry. Okay, we'll start with the right end. So, if I wanted to know, okay, if I wrote that out, that would be as x approaches positive infinity, okay, so as x goes out to the right, what is your y doing? Well, the way to actually figure that out, if we input positive infinity, okay, 5 times infinity minus 6 is going to be roughly positive infinity. A really, really, really massive number times 5 minus 6 will still be a really, really massive positive number. So we write, as x approaches positive infinity, now when I say approaches, you don't use the word approaches. Notice I'm drawing an arrow. This right here is just telling us, this right here is just telling us that we're talking about the right side. So now we write y and then the arrow, which really means approaches, and now we have to figure out, okay, what is the output doing as the input is getting more and more positive? Well, the output is getting more and more positive. So what we wrote right here is as x approaches positive infinity, comma, y approaches positive infinity. but you don't use the word approaches, you use the yield symbol. It's an arrow, like that. Okay, so now let's talk about the left end behavior of number 1. So if you're talking about the left end, you're talking about as x approaches negative infinity. So this first, before the comma, the statement before the comma is telling you that you're talking about what's happening at the left end as x gets more and more negative, and then we write y approaches, so y arrow. Okay, hopefully that looks like an arrow. Now to figure it out, you would really be plugging it in. 5 times negative infinity minus 6. 5 times negative infinity is going to give you a massive negative number, and then you take away 6, so you're going to be going to negative infinity. So notice, at the right end you're going up, at the left end you're going down. Okay, that's number 1. All right, number 2. So number 2 was, I'll write it up here. Number 2 was negative 4x squared minus 5x plus 2. Notice your right end, okay, let's do that. So as x approaches positive infinity, that means you're talking about your right end, okay? So if we wanted to figure it out, we would really be plugging in positive infinity, but remember, we're not actually getting a value here. Okay. Now, if I took infinity and I squared it, it's going to be positive. And then I multiplied it by a negative 4. That would be negative 4 infinity squared. This is a really, and then this would be minus 5 infinity plus 2. This would be a really negative number. Okay. Now, infinity squared. Okay, you can't even quantify infinity. So infinity squared is so big that these two terms don't even matter. Okay, these two terms are basically 0 compared to infinity squared. So all that matters when you're talking about end behavior, trying to figure it out, the only term that matters really is the first term. The first term. So is this a really large positive number or a really large negative number? Negative 4 times infinity squared. That's a really large negative number. So y approaches negative infinity. That's because if I take a really large positive number and I plug it in, that really large positive number squared is nothing in comparison to this value. These two terms are nothing in comparison to that massively large number squared. So these two terms are so small that they're insignificant. So if I take a really large positive number and I square it, and then I multiply it by a negative 4, okay, any number squared will be non-negative. But then I multiply it by negative 4, so now it's 100% sure, as long as it's not 0, but remember, it's a massively large positive number. If I square it and multiply it by negative 4, it has to be negative. Okay? Now the left end, as x approaches negative infinity, what's your output doing? Well, if I plug in negative infinity here, the other terms don't matter, okay? They're insignificant compared to the first term. Negative 4 times negative infinity squared. Negative infinity squared would just be infinity squared. So if I take a negative, massively large negative number and I square it, it's going to be positive. But then I multiply it by negative 4, and what is it going to be? Negative. Negative infinity. So both end behaviors go down. That has something to do with the fact that when I square a number, right, it's non-negative. If I only raise it to the first power, if it was positive, it's positive. If it was negative, it's negative. Number 3, your function was, this was x to the 4th plus 2x to the 3rd minus 5x plus 7. Okay, so let's take a look at the right end behavior. So as x approaches positive infinity, what is y approaching? Okay, Well, we can see by the graph what it's approaching, but let's talk about why it's approaching where it is, okay? The right end means you're looking as x gets more and more positive. So notice your first term is x to the fourth. These other terms don't really matter when you're talking about plugging in infinity or a massively large number that's going towards infinity, because these would be almost zero compared to the value of infinity to the fourth. So if I take infinity and I raise it to the fourth power, is it going to be a positive number or a negative number? It's going to be a positive infinity to the fourth power, right? Then, if I talk about my left end, as x approaches negative infinity, comma, y approaches. Now think about it. If I plug in negative infinity and I raise it to the fourth power, is it going to be positive or negative? It's going to be positive. So both of them, both ends, the right end as x approaches positive infinity and as x approaches negative infinity, both outputs are going up to positive infinity. That is because if I take, doesn't matter if I take positive infinity or negative infinity, if I raise it to the fourth, I'm going to get the same thing, a non-negative. And not zero, just a large positive number. And number 4, this was negative 3x to the third plus 3x minus 5. So if we look at the right end, which is as x approaches positive infinity, let's talk about what is y approaching. So you need to make sure you're using, this is called proper notation, okay? Make sure you are using proper notation when you are discussing the end behavior. So the right end, okay, is as x is getting more and more positive, what is y doing? Okay, so if I plug positive infinity, and I really only care about my leading term, I take positive infinity, I raise it to the third, that's going to be positive. But then I multiply it by negative 3, so it becomes negative. Now the left end, as x approaches negative infinity, what's y going to do? Okay, so negative infinity is negative x's. So if I take negative values and raise them to the third, they're going to be negative. But then I multiply them by negative 3, they're going to be positive. So they go in opposite directions. Okay, so let's look at something. 1 and 4. 1 and 4. The end behaviors went in opposite directions. And 2 and 3, the end behaviors went in the same direction. 1 and 4 have something in common, and 2 and 3 have something in common. So 1 and 4 have something in common, and 2 and 3 have something in common. What is that they have in common? That is the fact that 2 and 3 are even degree, and 1 and 4 are odd degree polynomial functions. So what that means is, okay, 2 and 3 are even degree, not even, that means something else, even degree polynomials. So what that means in terms of the end behaviors is, okay, if I'm taking positive infinity or negative infinity and I'm raising it to an even power, I'm going to get the same number, okay? That's why the end behaviors are always going in the same direction. However, this one, the end behaviors are going up, and this one, the end behaviors are going down. The reason the end behaviors are going up here is once I raise it to the fourth, I'm not multiplying it by a negative number. So both our outputs are going to be positive. However, in number 2, I'm taking positive infinity and negative infinity and I'm squaring it. So it's going to be positive. But then I'm multiplying it by negative 4. So both end behaviors will be negative. Okay? So if you have an even degree polynomial, okay, the end behaviors go in the same direction. Okay? Odd degree, so let's look at 1 and 4. Notice, they go in opposite directions. The end behaviors, the right end goes down, the left end goes up. The right end goes up, the left end goes down. That's because if I plug in positive infinity, I'm going to output positive infinity. If I put in negative infinity, I'm going to output negative infinity. So an odd degree polynomial, the end behaviors go in opposite directions. Okay, now if you look, okay, this one, the right end is going down and the left end is going up. In this one, the right end is going up and the left end is going down. There are two graphs in which the right end goes up. There are two graphs in which the right end goes up. Number 1 and number 3. And there are two graphs in which the right end goes down. Number 2 and number 4. 1 and 3, the right end goes up. 2 and 4, the right end goes down. What do you think is making the right end go down? Think about that for a minute, okay? If you have to pause the video, then play the video and you think you came up with a response. So what's making the right end go down is the leading coefficient. So if you look at numbers 2 and 4, your leading coefficient is negative. What that means is, okay, I'm going to plug something in. I'm going to plug in, if I'm talking about my right end specifically, that means I'm going to plug in a positive number. Okay, if I raise it to the second, it's positive. Okay, but then I'm going to multiply it by a leading coefficient that's negative, so it's going to end up being negative. I take positive infinity, I raise it to the third, it's going to be positive. But if my leading coefficient is negative, that means as x goes more positive, my outputs are going to go negative. So when your leading coefficient is negative, your right end behavior will go down. Your right end behavior will go down. Now, 1 and 3, the right ends are going up. Now remember, the right ends are talking about as x approaches positive infinity. So notice, if I plug in positive infinity, okay, I'm going to get 5 times infinity. Infinity times a positive number is going to be positive. X to the 4th. Infinity raised to the 4th power is going to be infinity, right? A really large positive number. And I'm not multiplying it by a negative, so it's going to stay positive. Okay? So those are what you have to keep in mind. Okay? If it's an even degree, the end behaviors are in the same direction. If it's an odd degree, the end behaviors are in opposite directions. If the leading coefficient is negative, the right end goes down. If the leading coefficient is positive, okay, the right end will go up. So you don't have to do this work where you plug it in all the time. Okay, if you know that you're working with end behavior of a polynomial function, it has to be one of these 4 cases, okay? It has to either be even degree with a leading coefficient that's positive, an even degree with a leading coefficient that's negative, an odd degree with a leading coefficient that's positive, an odd degree with a leading coefficient that's negative, okay? So, on the next page, it says, to state whether each polynomial has an even or an odd degree, the sign of the leading coefficient, and then we have to write out the end behavior of each function. So that's what we're going to do now, the next page of our notes. So what we're going to do is go through and answer each of these. So here's the graph of number 1 on your worksheet. And first thing is this an even degree or an odd degree? Well, now that we know the difference between even degree and odd degree, okay, even degree, the end behaviors go in the same direction. Odd degree, they go in opposite directions. So is this an even degree or is this an odd degree? Since they go in opposite directions, number 1, this is an odd degree. Now, is the leading coefficient positive or is the leading coefficient negative? Well, look at the right end, okay? We can base this, we're looking at a graph of a function and we can tell whether or not it's even degree, odd degree, whether the function has a leading coefficient or any that's positive or negative. So for the leading coefficient, we look at the right end, okay? Is the right end going up or is the right end going down? The right end is going up, which means there is no negative leading coefficient that's taking a positive number because this is when x is really positive, our right end. The only way that inputs that are really positive can output something negative is if that leading coefficient was negative. So that means the leading coefficient is positive. So now we have to write out using proper notation our end behavior. So as x approaches positive infinity, what's our graph doing? Y approaches positive infinity. We don't even need the equation to do all this stuff. Okay, the left end, as x approaches negative infinity, comma, what does y approach? So look at the graph. At the end, your graph is going down, so the outputs are approaching negative infinity. Number 2, is this an even degree or an odd degree? End behaviors are going in the same direction, so this is an even degree. The right end is going up, which means there is no leading coefficient that can make these positive numbers negative. So the leading coefficient is positive. So our right end, as x approaches positive infinity, what does y approach? Okay, look, goes up, positive infinity. So now let's talk about the left end. The left end is specifically talking about as x approaches negative infinity. That is talking about the left side of your graph. What is the output doing? The output is going up, so that means y is approaching positive infinity. In the third, end behaviors are going in the same direction. This is an even degree. What is the right end doing? The right end are positive inputs. Positive inputs are getting more and more negative. That means the leading coefficient is negative. The right end, as x approaches positive infinity, what's the right end doing? The outputs are going to negative infinity. The left end, as x approaches negative infinity, your outputs are going to negative infinity. When you talk about your behavior, you're talking about what's the output happening, okay? So as x approaches positive infinity says you're talking about the right side, and the behavior is what is y doing at that right side. And the last one, they're going in opposite directions, so this is an odd degree. The right end is going down, so the leading coefficient is negative. The right end, as x approaches positive infinity, y approaches negative infinity. And the left end, as x approaches negative infinity, y approaches, look at the left end, positive infinity. Okay? So, next thing we're going to do is summarize the end behaviors of any polynomial function.